We want to prove this one. So we will start with a quantity epsilon is greater than 0. For any epsilon greater than 0, we assume that we try to find a delta which is greater than 0, and delta will depend on epsilon. And then delta is defined as, if we can define delta as the difference between x and 1, because x is approaching 1, not quite 1. So the difference between x and 1 is less than delta. The magnitude of the difference is greater than 0 but less than delta, and delta is also less than equals to 1. And if we do that, then by starting with this one, if we can show that x square plus 1 minus 5, this one is less than epsilon, if we can do that, and if we can relate delta with epsilon, then our proof is done. So first we have this one, x minus 1 less than delta. Now this is a magnitude. We can write it like that because delta is less than equals to 1, so this will be less than 1. So if we take the plus sign, we get x minus 1, 1. From here we get x 2. And if we take the negative sign, then we get minus x plus 1, and this is 1. So that becomes minus 1 minus x, and then this becomes 0. So we can write it 0 is greater than x, then 1. So together we can say that 0, 2, where x is not equals to 1, of course. So that one we have. Now if we go back to this one, and we need to get this one to be less than epsilon, and we need to have a delta accordingly, basically. So this can be written as x square minus 1, and this can be written as x minus 1, x plus 1, which is there, and x minus 1 is less than delta, and this one is less than 2, so we can write it to be less than 2 plus 1, 3, so less than 3 delta, basically. So if we can choose delta to be, so from here we get that delta has to be epsilon over 3, basically, because we want this one to be less than epsilon. Also we want that because that's what we want to finally achieve. So if we can choose delta to be epsilon over 3 or 1, whichever is minimum. So if delta is 1 or epsilon over 3, whichever is minimum, if we can choose that, then we can get this one. So hence the proof. In the next video I will consider some numerical value for the same problem. So that's what I will do.